Everyone, I am Ajay Kumar from Mechanical second year. My topic for concept video is sample spaces and events in probability. Sample spaces and events. First of all, definition. An experiment is an activity or process whose outcome is subjected to uncertainty. Is called as random experiment. Although the word experiment generally suggests a planned or carefully controlled laboratory testing situation, we use it here in a much wider sense. Thus, experiments that may be of interest include tossing a coin once or several times, selecting a cards from a deck, weighting a loaf of bread, ascertaining the commuting time from home to work on a particular morning, obtaining blood types from a group of individuals, or measuring the compressive strength of different steel beams. Sample space of an experiment. Definition. The sample space of an experiment is denoted by S. It is the set of all possible outcomes of that experiment. For example, if two coins are tossed, total outcomes are two tails or two heads, or one coin showing tail and other showing head, or one coin showing tail and other the head. There are four outcomes. This is the sample. The sample space is 4. Simplest experiment to which probability applies is one with two possible outcomes, like a coin with tail and head. One such experiment consists of examining a single weld to see whether it's defective. The sample space for the experiment can be abbreviated as sample of set of n comma d, where n represents not defective, d represents defective, and the braces are used to enclose the elements of a set. Another such experiment would involve tossing a thumb back and noting whether it landed up or point down, with sample space S equals to set of u comma d. And yet another would consist of observing the gender of next child born at local hospital, S sample space. Events. In our study of probability, we will be interested not only in the individual outcomes of sample space, it also various collections of outcomes from sample space. Definition of event. An event is any collection or subset of outcomes contained in sample space S. An event is simple if it consists of exactly one outcome, and compound if it comes of more than one outcome. When an experiment is performed, a particular event A is said to occur if the resulting experiment outcome is contained in A. In general, exactly one simple event will occur, but many compound events will occur simultaneously. Consider an experiment in which each of three vehicles taking a particular freeway exit turns left or turns right at the end of the exit ramp. The 8 possible outcomes that comprise the sample space are 3 cars taking left, 1 taking right and other 2 left, and so on to 3 taking right. Thus, there are 8 sample events, among which event 1 is 3 taking left and event 5 is 1 taking left and the other 2 taking right. Some compound events include the event that exactly one of the 3 vehicles turns left, and the event that at most one of the vehicles turn right, that is maximum one vehicle turning right. And here the event at all 3 vehicles turn in same direction is taken as, suppose that when the experiment is performed, the outcome is three cars taking left, then simple event E1 has occurred, and so also have the events B and C but not A. Some relations from set theory. An event is just a set. So relationships and results from elementary set theory can be used to study events. The following operations will be used to create new events from given events. Definition: the complement of an event A denoted by A dash is the set of all outcomes in sample space. The union of two events A and B denoted by A union B and read of A or B is the event consisting of all outcomes that are either in A or in B or in both events. So that union includes outcomes for which both A and B occur as well as outcomes for which exactly one occurs. That's all outcomes is at least one of the events. The intersection of two events A and B denoted by A intersection B and read A and B is the event consisting all outcomes that are both in A and B. For the experiment which the number of pumps in use a single 6 pump gas station is observed as set A is equals to 0, 1, 2, 3, 4 and set B equals to 3, 4, 5, 6 and C equals to 1, 3, 5. Now A complement is out of 6 we have only 4 up to 4. So total remaining 5 comma 6 will be A complement. And here A union B means set of A and set of B is united and the common elements are taken as 1. Same for A union C, and here A intersection B. We take the elements which are common in both the sets. And here finally A intersection C complement means we take the elements which are not common in the both. Sometimes A and B have no outcomes in common, so that the intersection of A and B contains no outcomes. Let phi denote the null event, the event consisting of no outcomes whatsoever. When A intersection B is equals to phi, A and B are said to be mutually exclusive or disjoint events. A small city has 3 automobile dealerships: a GM dealership, Chevrolets and Buicks, a Ford dealer selling Fords and Lincolns, and a Toyota dealer. If an experiment consists of observing the brand of the next car sold, then the events A is equals to Chevrolet and Buick and B equals to Ford and Lincoln are mutually exclusive because the next car sold cannot be both a GM product and a Ford product, at least until the two companies merge. The operations of union and intersection can be extended to more than two events for any three events A, B, C. And A union B union C is the set of outcomes contained in at least one of the three events, where A intersection B intersection C is the set of outcomes contained in all three events. Given events A1, A2, A3, these events are said to be mutually exclusive or pairwise disjoint if no two events have any outcomes in common. The pictorial representation of events and manipulations with events is obtained by using Venn diagrams. To construct a Venn diagram, draw a rectangle whose interior will represent the sample space S. Then any event A is represented as the interior of a closed curve of a circle contained in sample space. These are some Venn diagrams. First one showing the Venn diagrams, the of set A and B, which some elements are in common. Second one is A intersection B, third one is A union B, and fourth one is A complement, which means set of A remaining the whole total universal elements. E represent mutually exclusive, means there is no common elements. F represents A union B union C, and shaded region in G represents A intersection B intersection C. That's all for the topic. Thank you.